All right. So we're live and very happy to be here. I hope all of you are staying safe. I know that some of you are probably moving about a little bit more than before, but do stay safe. Don't take chances. This is pretty nasty. Hopefully, everyone can stay safe. So, just a quick introduction about myself. My name is Abhay. I had a company called V45. I do a lot of these sessions. I head technology at V45, which gives me the ability to do a lot of these sessions around serverless, around the cloud, Kubernetes, and so on. I largely started off as an offensive tester, mostly penetration testing, but then today I've moved more towards a builder come breaker role. So I do a lot of different types of things in terms of research and mostly defensive security research. I also train at Black Hat. In fact, we have a bunch of training at different events around OWASP and Black Hat and so on. I'm also part of a very interesting open source project called Threat Playbook, which is a focused threat modeling as code project. In fact, I'll take some aspect of that as I talk about a little bit of the stuff that I do today from this particular project. As always, just a quick mention of our classes. We're running a bunch of remote training encompassing all of these different subjects. Our trainings are pretty awesome. All of our our trainees have thought so. We've not had a bad review. So we have trainings around DevSecOps, cloud security, Kubernetes, containers. And aside from the great training, you also get access to the labs even after the training. You also get access to the videos after the training, and you also get a shot at certification. So it's really cool. You want to prove your knowledge to the world, you should come and do one of these courses or more of these courses, depending upon what you want to do. DevSecOps, we're running a promotion. You have DSO 200, you get $200 off. That's $200 off any of our DevSecOps courses. It's a pretty sweet discount. We also have other codes like Web and Sub for any other course as well. So this is what we have May and June. So do sign up for one of our classes. They're pretty awesome. YouTube, as always, we're going to be streaming on this channel, V45-AppSec. We have a blog at v45.com. And of course, if you catch us at one of our several talks at different OWASP events, then I'll see you there in one of those talks as well. So in the meantime, let's get started with today's subject, right? Let's get started with what we want to be doing today. Just excuse me a bit while Right, so let's get started with today's point, which is a serverless app, and we're going to be doing a rapid threat model with our serverless application, and we're going to be using that rapid threat model to be able to actually design some security controls. Now, I don't know how many of you have done threat modeling. So if you have, just put it in the comments. If you are doing threat modeling, put it in the comments. I'm going to ask you all a question. Now, how many of you find threat modeling to be a pain or a very difficult process? Show of hands. If anyone is on the channel, show of hands, let me know if any one of you find threat model to be a pain. I can imagine that it's a pretty complicated thing to do, and it's getting more and more complicated, especially as the stacks are growing and we have a lot of different technologies that we're using, right? So threat modeling, especially the way it has been done traditionally, is a problem, right? Because it's slow, it's system-wide, and it's essentially, by the time you even finish your threat model, it's probably, the application itself has changed quite a bit. So the threat model eternally tries to catch up with the application, but can never do that. In fact, in my threat modeling trainings, we constantly talk about the fact that this is a problem and how you can get past this. So one of the approaches to doing threat modeling is an approach called story-driven threat modeling. In most threat modeling scenarios, you have something called system-wide threat modeling. Now, system-wide threat modeling is threat modeling the entire system, right? You take the entire system and you threat model that system. So all of the moving parts of that system, or you threat modeling that system at any given point in time. The problem with threat modeling an entire system is that it becomes very difficult for you to be able to actually finish that threat model quickly. So let's say you're doing an agile sprint. Most of us work in agile environments. We work with sprints. We work with fast-paced development. Continuous delivery is our main go-to thing. So when you have scenarios like this, you don't really have the time to sit and do a large 2-week, 3-week, or a month-long threat model with all the diagrams and all of the beautiful stuff that goes with it. You want to do a rapid threat model. You want to be able to do a threat model fast. You want to be able to get it done quickly, and you want to be able to move on from that threat model as fast as you can. So you want to be able to threat model fast, and obviously you can't do an entire massive system rapidly as a threat model. Right. So what I teach in a lot of my classes is story-driven threat modeling, right? Where you're essentially, so most of us are used to the concept of user stories, right? Now, user stories are typically features that, so we have a couple of comments. Thanks for that. Scoping is an all-important aspect of developing a threat modeling program. Absolutely. So let's look at the scope. And with that, let's talk about a little bit of the scope. Right now, scoping is one of those things that helps you define or drive a threat model. And in my case, what I would like to see done is scoping a smaller scope or an iterative scope in your threat model, so that you can ensure that you get a great amount of coverage, or you can give that particular set of stories a great amount of threat modeling coverage. So instead of threat modeling a system, which is that big, which is huge, threat model stories, which are essentially taken up in the sprint during sprint time, just threat model those stories and then move on. Now, is this perfect? Obviously not, because threat modeling in its nature has a lot of improvement. It's continuous improvement, but this will help you move fast. It also helps you get a very specific set of outcomes from the threat model. So one of the big challenges, and I hate this, that happens in our industry all the time, we don't have threat models with outcomes, right? All of our threat models are based on these theoretical models that are in the air, and it becomes really, really complicated to quantify and make sense of them. We don't get security teams itself to use threat models. So that's one of the big challenges that we always run into. So my thing is that always make sure that your threat models are actionable, that they actually have something that you can use, that you can hand out to different teams. So let's say your threat model produces great mitigations, then give it to your development team, your ops team, your cloud team, your threat hunting team. So you should be able to use your threat model for something. That's what we want to get at. Now, in this session, obviously, I'm not going to be able to give you the whole length and breadth of the whole thing, but I'm going to try and dive in to one aspect of threat modeling. So I'm going to do a serverless threat model, right? And why serverless threat model? So in a serverless scenario, I love serverless for that one reason, right? Serverless, you have a function as the unit of compute. You're not modeling a system, you're modeling a function. Right? So when you're modeling a function, remember, you're just modeling a single piece of functionality, right? Which means that you're modeling that single piece of functionality, and you can apply all your threat modeling aspects to that function. So let's say in a particular agile sprint, you have a bunch of folks who say that, hey, we're taking up these many functions in this sprint or in this particular sprint. In your sprint planning meeting, you should do your rapid threat modeling that looks something like this. Right, so I'm just going to quickly share this slide deck. I'm not sure if all of you can see it. I'm going to just try and blow it up because it's a little small. So basically, it starts with the story or the feature or the function itself. So it starts off with that. Then you create something called abuser stories, which essentially means how can that functionality be abused? How can that be compromised? How can that be actually, beaten in any way, right? Now, this, remember, is a high-level business description of a threat. Right? It's not a technical threat definition. It is essentially a business description of a threat. So what we want to do is we want to be able to get at an abuser story, because you're doing it. Remember, when you're doing a threat model, you should do it as a cross-functional team and not as just as a security team. You should only do it with a cross-functional team so that everybody else can also understand and contribute to your threat model. Not just security folks, but also business analysts, also senior members of the developer team, or architects, and so on and so forth. So you should have a cross-functional threat modeling team. So you have user stories, you break that down to abuser stories, then you break that down. So you take abuser story and essentially say, hey, how can this abuser story be brought to life, right? How can I make this abuser story come to life? And that's when you create your threat scenario, which is essentially, hey, I have this abuser story, and this is how I bring it to life with a SQL injection attack, or I do a man in the middle, or do this or that, or whatever it is, you bring it to life. From there, you essentially diverge to 2 points, where you start defining mitigations, which you give your developers. Then you can even define things like security test case or acceptance tests, where you can say that, hey, this is what we need from this user story, or these are the security aspects or constructs we need from this user story. use this and come up with mitigations, use this and come up with test scenarios. And that's what we want to do with this scenario. Okay, so I'm going to be doing, while I've defined some of the code in the beginning itself, I'm not going to be doing live code in the truest sense of the term. But the idea is that I just built this 2 hours before the session. So the idea is that I walk you through this because we don't have all the time in the world. So let's get started. Okay, so we have our, let's start defining a threat model. And I'm going to increase my screen size and reduce this, right? So let's call this a threat model for a login feature. So let's say I have a serverless function that allows me, that I'm going to define a threat model for. Okay, so I'm going to say tm.md. So this is a markdown. I think Mac just confused that for a trademark. That's weird. Anyway, so essentially this is a login feature. We want users to use their username and password. So essentially, as a user, I want to be able to use my username, or sorry, not my username, my email and password to log in to this API. So let's say we're developing a serverless API. So we have an API gateway. So it's basically the user who talks to the essentially the API gateway, and this invokes a login function, and which obviously pulls data from DynamoDB and validates the user's credentials against whatever stored in the database to ensure that that user is a legitimate user. So this is a very simple login function. So I'm going to implement, let's do a little bit of a threat model or a rapid threat model against this login feature. So let's look at the abuses for this, right? So one of the key abuses, as I'm sure you probably can see, is that you have the possibility of account takeover, right? Where someone, an adversary of some sort, will be able to compromise some user's access and be able to gain access to their account by compromising or taking over their account in some way. Now, remember, at this point in time, we want to keep it as a business description and not a very technical description. The reason for this is we are doing it with a cross-functional team, which means that everybody should be able to contribute, and not everybody understands very, very specific security jargon. So always try and keep it to a to an audience where they understand abuse or they understand business risks. That's very important for us to understand business risks, because remember, security folks may not understand all business risks, and business people may not understand all security risks. So you have to kind of form this amalgam between security risk and business risk. And business risk, if you might see that security risk is but a subset of business risk. So it's actually good to define things in simple language that people can understand and actually use. So account takeover. So which means that I will be, as an attacker, I will gain access to the user's account on this API. Basically, that is one of the biggest things that I'll see, right? So that is one of the major abuses that is possible against a login functionality. In fact, if you think about any login, this typically involves defeating authentication. So since login is an authentication control, things that defeat authentication typically are spoofing and elevation of privileges, right? So if you look at the STRIDE model, which is spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege, largely the STRIDE, the STRIDE threats that are applicable to a login feature would be spoofing and or elevation of privilege. So that's typically what we're going to be looking at. So let's start to define the threat scenario. Okay, so let's define the threat scenario. So how can I make this happen? So remember, I just have an API where I can log in with an email and a password, and I get a token. So, and I get I receive an auth token post login, right? So that's basically what's happening here. So let's look at the threat scenario. So we've decided that abuses is account takeover. As an attacker, I will gain access to the user's account and compromise the user's account, take over the user's account. So the threat scenarios, how could this abuse actually come to life? That's our focus. Remember, we are scoping it to very specific things. So we want to make sure that we don't do we're not taking up an entire system. We're only taking up that one feature, and we are scoping our threat model to that feature. So, which is very important for all of you to understand. So, one of the threat scenarios you can obviously do is, brute force the password, brute force user credentials. This is a very common thing. I'm sure all of you have seen this. Some of you who have done pen testing or something a little bit more dangerous than pen testing have probably done this against live systems. So brute forcing user credentials is a very standard thing. The other thing you can do is potentially do some kind of injection or elevation of privilege on the database, right? So which means that you want to be able to gain access to the database itself, and then through that, you want to be able to compromise the user account, maybe steal passwords or whatever it is from that point onwards. The other thing you want to do is, or you could do, is person in the middle attack. So essentially put in some kind of sniffing and try and capture credentials as they are being sent over the wire. That is one possibility of the type of attack that you can do with when you're trying to do an account takeover. Or let us say you could do person in the middle. I think I wrote down a couple of more scenarios here. Yeah, I think we have a few more scenarios here, which is passwords in plain text, right? This is another thing. So let's say the passwords are stored in plain text. So when plain text passwords or weak hash, weak encryption used to protect passwords. So let's say this is against internal threats. So somebody internal can potentially compromise your password when they're either plain text, or if somebody can do the injection or elevation of privilege on the database, then you can potentially do plain text passwords as well, right? So then that is something that you can do. And I think I've written down one more, which is the auth token itself getting compromised. So let's say the auth token is compromised. Now this is kind of out of scope, I would say, but then let me just capture this as well. Auth token through some means, like maybe cross-site scripting or whatever it is, maybe used to compromise the auth token from the browser or from some other client environment. So now that we have, as you can see, that we've kind of defined the threat scenario for this feature. And the cool thing about this is that we didn't spend too much time actually thinking about the threats, right? The idea here is to not just come up with threats. The idea here is to come up with mitigations and tests. Just like you need to battle COVID-19, you need to do a lot of testing. To ensure that your application is secure, you need to do a lot of testing, right? The same thing applies anywhere. So this helps us in multiple ways. So once you come up with your threats faster, you should also be able to come up with mitigations and tests much faster, right? So, and that's the big benefit. And one of the other things, I'm not sure if some of you have figured out by now, is that once you do a job of this for a feature, if you're building a similar feature in the future, you should be able to use the same threat model or a very similar threat model and just extend it to that particular feature. In fact, in Threat Playbook, you can capture all of these threat scenarios or these threat models as YAML, and you should be able to reuse them very quickly. So that's one of the things you can do with Threat Playbook, which is the open source project I was working on. So I'm going to post the links at the end. I don't have time to post the links, so I'll just be posting the links at the end, right? So the idea here is to be able to reuse the threat models, to be able to generate these threat models fast, and to be able to get moving as fast as you can. So let's quickly define some mitigations and some test cases. So brute forcing user credentials. Now, obviously, have password strength. Ensure that you have password strength. Ensure that you have some kind of rate limit on your API, maybe a client-based rate limit or an IP rate limit, depending upon what you want to do. Maybe some kind of lockout definition for your passwords, right? So your password attempts. So that's something you can do. So as you can see, we have quickly defined our mitigations for brute forcing user credentials, password strength, rate limit, lockout, password attempts. Injection EOP. Remember, we are using DynamoDB, so we are not traditionally vulnerable to SQL injection. So we're not going to add SQL injection here. It's pointless. However, IAM misconfigurations on DynamoDB can still result in elevation of privilege, right? So if your function gets a lot more privilege to that database, it means that potentially if somebody is able to use some loosely scoped queries, they should be able to compromise that. In fact, I have discussed this in a blog and a technique that I found last year called DynamoDB injection, and I spoke about this in many events as well as our serverless trainings as well. So IAM misconfiguration is one of the big challenges. Elevation of privilege on the database, that's one of the big challenges that we face. Nothing more than that. So that's something that you'll see. So avoid IAM misconfiguration, or test for or validate IAM misconfiguration on the DynamoDB for EOP. PITM, or person in the middle, we have the obvious control. Amazon gives us HTTPS by default, which is cool. So if you're using a Lambda function or a set of Lambda functions on AWS, you have HTTPS on the API gateway. You don't need to worry about this so much. You probably just need to make sure that you have additional stuff like HSTS and CORS set up maybe for, to prevent additional types of data leakage. But largely, we're dealing with this. We've dealt with this, right? So the other thing, obviously, protect passwords are going to be crypted. Now, if you're using SSO or something like that, you don't need to worry about this so much. In fact, you can see that some of this can quickly be descoped in your own environment. So let's say you're using Lambda with Cognito or something like that. You should be able to descope a lot of these things, because the single sign-on system itself can be configured to take care of some of this. So a lot of this can be achieved through configuration. A lot of this can be achieved through code and so on and so forth. Of course, in this case, we're not using any of that. So that's why I said protect password to bcrypt. And with auth token, obviously issue short-lived tokens. Use strong passwords to generate the tokens. So you can see that within 20 minutes, we've been able to identify this. Of course, with me explaining a lot of this stuff, it's taken 20 minutes. More mature teams, as you go through this process, feature by feature, you should be able to move at a much faster pace. In fact, as you do this process, in fact, we have done story-driven threat modeling for many of our clients, and you see that over time, they actually spend less time doing threat modeling than more, because they've already built on an avalanche of gains that they've had doing previous threat modeling efforts. So that's one of the things you can do. So you have all of this stuff. So pretty much, so with this, you can see that we can quickly even arrive at security test cases. So password strength, let's say we want to ensure that entropy of the password is at least 30 bits, right? So rate limit, let us say you have 100 requests per second. So let's say we define this as a test, right? Lockout password attempts, you can easily simulate that with functional testing, not a problem. Ensure that you run some kind of tool to do IAM misconfiguration, maybe run Cloud Custodian or some other tool to be able to identify IAM misconfigurations. In fact, there are a bunch of tools that can do this. HTTPS, maybe run some kind of SSL test tool to be able to identify this, maybe some CORS test tool to be able to identify CORS-based misconfigurations. This is pretty easily doable with some static analysis and maybe some code walkthroughs with the developers and the with architects maybe. Short-lived tokens, make sure that you actually validate. This is very easy to validate with JWT. All you have to do is look into the payload and you will see that it's a short-lived token or not, right? So that's basically JWT payload check. And for EXP and maybe IAT claims to make sure that when it was issued, when it expires is essentially within, so let's say you want a 1 hour kind of a thing. So let's say you want a 1 hour kind of an expiration, you can probably do that. Strong passwords to generate tokens, this can easily be achieved with static analysis, code walkthroughs. It can be achieved with a lot of other things, but these are the easiest things that it can be achieved with. So as you can see, within 20-30 minutes, you've been able to identify a lot of this stuff. Now let's actually implement this on our stack. Right. So the first thing I want to do is look at our serverless. So I'm going to be using the serverless framework to be able to deploy this. And let's start with our first thing. So one of the plugins I discovered to be able to do this was, and I'll talk about the problem first and then talk about the solution. So one of the problems with standard serverless functions is that you have to define only one IAM role statement, which means that that entire IAM statement is applicable for the entire stack. Now that's a problem. And that's an issue simply because, let us say I'm writing data to the database. I don't need to have read access for that function. That function, that serverless function, does not need to have read access, right? It only needs to be able to drop an item into the database, nothing more, nothing less. So that's one of the things you should do. So this plugin allows you to define roles per function, right? So it allows you to define an IAM role per function, and I started using it. It's pretty cool. It allows you to do that. So let's look at what this allows me to do. So first, I've defined a DynamoDB, which gets created with an email as the primary key or as the hash key. in DynamoDB. And then let's look at the functions itself. So we have a login function. Remember, the login should be able to query the database and actually retrieve usernames and passwords. So it needs to be able to do a get item and a query. So both these things are allowed against this one table, right? So you can see that this function only has this privilege, which means that we're effectively dealing with this particular case quite comprehensively. So it's able to get item and query. If you look at the sign up function, which allows users to sign up, it only allows that function to do a put item. So if that function is, let's say that function is compromised and somebody is able to backdoor that Lambda, they can't do anything more than DynamoDB put item, right? So it's very, very tightly scoped. The access privileges are very, very tightly scoped to that one thing that they can do with this particular function, right? So you can see that with the configuration, I've been able to restrict the functional scope to a very specific set of access privileges that I only want. The thing I've also done as a generic rule is put log events, which means that all of these functions inherit from a single role statement that allows you to put log events and nothing more. It just allows to put log events. I can tighten this up a little bit more, but just for the sake of this demo, I'm just using put log events on star, right? I would recommend that you try and tighten this up a little bit as well. All right, so let's look at our code and deploy our code. So the first thing we want to look at is password strength. So we are using a password strength policy library, and we are ensuring that the entropy for that password is 30 bits or more. So it will always check for entropy of 30 bits. If the entropy is not 30 bits, it would reject the password. If the entropy is more than 30 bits, only then it would accept that password, which means that we're dealing with this particular brute forcing possibility quite well. I'm not put in a rate limit, but it's quite easy to do that with the serverless.yaml. Lockout password, this is something that you can potentially implement as part of the same login feature, right? So let's look at that lockout and also log invalid access attempts. That's also something that we want to do. That's another control that we just figured out, right? So sign up, when the user is signing up, the user signs up, it already tests the user's password against the password policy. If the user meets that password policy, then the user signs up. We are using bcrypt to generate the password hash, which also meets our strong password plain text, the password strength and storage requirements, which is pretty cool. We're using bcrypt. So in this case, we're using bcrypt to be able to store passwords in the database, which is a good thing. And we're using bcrypt's salt per hash that it uses. So we're not using a static salt. It's always good to use a salt per entity kind of a system. Then, so we're using that as a sign up function. As you can see, we are logging all events. So every time there is an error or a successful event, we are logging all of this stuff, which is an important thing. Remember, one of the things that people often tend to ignore with threat modeling is the ability to include monitoring controls in that threat model, right? So you should definitely be threat modeling not only preventive controls, but also a boatload of detective controls. It's not just good enough to threat model preventive controls, not nearly enough. Definitely look at detective controls as well. So logging is another thing we've done. Now, the feature that, of course, we were intending to threat model in the first place, which is the login feature. So the first thing we're doing is we're checking if the mandatory parameters are not in there. If it's only if the mandatory parameters are in there, we are using DynamoDB to query the email. If the email does not exist, we throw up an invalid credentials error on screen. And of course, the user, we log that as a invalid access attempt. And if the user's password is checked and the password is not found to be correct, then again, we log an invalid access attempt. This time, we tag that invalid access attempt to that particular user. So not only, so we are ensuring that all of these things are being done. You can see that protect passwords with that, and of course, log invalid access attempt. All of these things are being done as part of this model. Right. The next thing we're doing is as soon as the password is found to be correct, we're generating a token, and you can see that the token has an expiration time of 1 hour. So which means that we're even achieving our last one, which is if in fact the auth token is compromised, we're issuing a short-lived token, and we're using a strong password to generate the token. So in this case, you can see that we're using, I think we're using, let's say, sorry, let me see where we're doing. Oh yeah, here we are. we're using a secret Python secrets library, and we're using the URL safe secret to be able to generate that JWT. So that's essentially. So you can see that within not a very long period of time, I'm sure you'll agree, we have been able to completely model a story, right? And with serverless, that can take it to the next level, simply because serverless has the ability to introduce very granular controls in a serverless function or a serverless stack is very powerful. So you should definitely be taking the same kind of principles even to a monolith. So even if you're threat modeling a monolith, go by feature and not by system, right? Because the system is huge. It will take at least a few weeks, or if not a few months, to be able to threat model that entire system. And by that time, that system's already changed 20, 30, 50 times over. So one of the things you should definitely be doing when you're threat modeling this is to ensure that you have a feature-based, story-based approach. Now, finally, let's deploy this to our AWS environment. I'm going to do SLS deploy, and it's going to deploy our stack to AWS, and it's going to create all the necessary dependencies to be able to run this stack. And we're going to actually validate whether our controls are working, right? So let's see whether our controls are actually working. In the meantime, if anyone has any questions while the stack is getting deployed, I'll be happy to take those questions at this point. I do see a lot of comments. Thanks for some of these comments. I'm going to quickly paste some of the comments on screen. So this is remote code training, some interesting comments as well. Yeah, so this is from John, who's posted an interesting comment. Another interesting comment from John. Yeah, so this is pretty cool. So John has said, in this case, internal library of threat scenarios. This is exactly what you should be doing with threat modeling as code. In fact, threat playbook, which is the library that we've built. In fact, we're launching the new version of that this weekend sometime. So that is a pretty cool library that helps you do this exact same thing. So create that internal library of threats is something you can do. So check out this link, start this project, and get involved. We are also working on a lot of docs. Threat modeling is complicated, so we're working on a lot of different approaches to this. So we'll be happy to receive your input on any of this. Our stack is still being deployed. I'm just waiting on this for a while. Just give us a few minutes. So as you can see, our stack, remember, we have tried to address a lot of these security controls. Obviously, some I've not been able to directly do because it requires a lot more configuration, and I'm not going to be able to display it in a few minutes. But as you can see, we've been able to achieve most of these things with our serverless stack itself. So it's pretty cool. We've been able to get some very quick threat modeling wins for our stack in itself. So it's just updating the stack. As you can see, I'm going to hide this. Our stack is almost done. I think it's going to be done soon. Yeah. So we have our stack ready and up and running. So I'm going to first sign up as a user, and I'm then going to. So let's sign up as a user. I'm going to use the HTTP CLI to do this. So I'm going to make a request, email admin@admin.com. I'm going to sign up with this password. Let's say super secret password, right? So this clearly definitely meets the entropy 30 requirement, 30 bits of entropy. I'm quite sure it meets that. Let's add 1, 2, 3, 4, 5 just to be sure. I'm going to sign up as the user. Yeah, so you see that the user is successfully signed up, right? So let us say I used a really crappy password, like let's say admin@live.com, and password is 1, 2, 3, 4. Then hopefully you should see that we have a password entropy requirement that it needs to meet. So clearly that doesn't meet that. Now we've signed up as admin@admin. So when we log in, remember, we should simply get back our token. So let's just go back and do a login on with the same email and password. So when I log in, I should get a successfully logged in with my KWT. And as you can see, so now let us say I do a log-f sign up. You should see that our logs-f. You see that our security errors have been logged. So you see that admin@live.com's password does not meet validation requirements. So let's say I try and do a brute force, right? One of the things we look for is brute force. Let's say I try and log in with a wrong password. Let's say instead of this, I log in with 12345. Obviously, it doesn't meet that. It's not the right password. You should see that it gives you an invalid credentials, and this is of course logged as a as an event in our logs. Of course, I've just logged it as a plain, an STD out, but you can do a JSON and push it to a centralized log environment and do much more analysis with it. Or you can even take event-based action based on this. So let's say you're seeing like a series of events with invalid access attempts, then it could mean that somebody's trying to do a brute force. You could take potential additional action against that user or that particular source of traffic from where it's coming from. So with that, I just wanted to, that brings us to the end of our session today. So what we did in this session, just a quick summarization, we talked a little bit about threat modeling. We talked about the fact that threat modeling done at a system level is good. I'm not saying it's not good, but it takes time. It's time consuming. It doesn't work at scale. It doesn't work at pace. So you should be able to do things like story-driven threat modeling, where you should be able to drive this at at a very localized story-driven user story-based level. We also discussed how you can do that at a much more rapid pace than otherwise. So we do this as part of our agile threat modeling trainings as well, where we teach teams to do a cross-functional threat model with user story, abuser story, threat scenarios, and then segueing into security test cases and mitigations and so on. Of course, that should help you define mitigations and test cases, which you should be able to run within the same SDLC itself. So that really becomes a very powerful way of handling things. And of course, as you can see, as the rubber met the road, we were able to implement the same thing against a serverless function or a serverless stack that we just got up and running in a matter of a few minutes. So I hope you enjoyed this session. As always, please feel free to write to us. And like I said, again, we're running a bunch of remote trainings over the course of May and June. So please, if you're interested, register for one of our trainings. If you're interested in doing this training for your own organization, get in touch with us at v45.com. Just fill in a form, and you should be able to do that. That's our discount code for all the DevSecOps courses that are happening over May and June. That's really it. Thank you so much. Thanks for all the comments from John and others. Really appreciate the shout outs and really appreciate the comments. We are going to be back next week with something else, hopefully equally interesting, if not more interesting, on different topics around application security. Thanks a lot. Stay safe and have a great day. Have a great evening wherever you are, depending upon wherever you are. See ya. Bye-bye.